because the explanation given there is a little bit unclear.
It's our technology. Capital per worker and output per worker. We have technology with diminishing marginal product of capital, yes, diminishing returns. Technology, how to produce. I didn't get the question.
Oh, I mean, this question was in the Socrates, so this is why I asked it. Like, so how do we describe this line that goes like this, like that you just expressed?
This one?
Yeah, this one.
It's technology, how to produce output, what?
Well, never mind then.
Which kind of dependence between capital per worker and output per worker? Direct ratio. No dependence, no. Randomly, no. Indirect ratio, no. Direct ratio.
Okay, I get it. Thank you.
Okay. So, okay. Let's start our class. Today we'll talk about the Solow model, but we will not count anything. We will discuss like intuition. So please open class 10. We'll start with problem 1. I think you are prepared if you ask these questions from the lectures. So it will be easy. So number 1, let's read. The Solow model shows that the saving rate does not affect the growth rate in the long run. Let us write down. Saving rate in the economy has no effect on the growth rate in the long run. No effect on growth rate in the long run. So we should stop worrying about the low saving rate in our country. So that's why no worry about saving rate low. And increasing the saving rate wouldn't have any important effects on the economy. So if we will increase this low saving rate, we will see no important effect. So this is the statement, and we should answer, is it true or false? Do you agree or disagree? Please, arguments for once. So one more time, the argument is we should not worry about low saving rates in the economy, and because if we will increase it, we will have no important effect. Please. Next.
I'm not sure, but in general, I think it doesn't work like this. So actually, it should be false. I don't know, like because. I don't know how to explain, but for me it seems just to be false. It just not seems correctly. I don't know. Maybe you will explain it more. I mean, in details.
Okay, we can consider this like polar situation when we have a super low saving rate. Let's consider. Let's draw the situation. Very low saving rate. Let's see. So here, capital per worker. So this is output per worker, technology, output, as a function of capital. Then here, depreciation rate multiplied by capital per worker, and this is depreciation of capital. Yes, where depreciation rate is constant. Then, and if we will have what that means, we have output. Output is our income. Remember SLM, yes? Output is our income, and what we do with our income. Part of it we save, part of it we consume, yes? So, if our saving rate is low, that means that we save a little bit and consume a lot, yes? So, how to show the amount of savings? We should multiply our income or output by the saving rate. And if it is small number, it will be like this. Yes, multiplied by the output. Yes, this saving rate is low. And what we will see? In the steady state of the economy, when capital does not change, not grow, not become lower, when depreciation equals to the investments, yes, no change in capital, what we see? We will have very low amount of capital per worker and low amount of output. Yes? Why? Because if we save a little bit, savings are always equal to investments. Yes, and when we save a little bit, we invest a little bit, so our capital is small, and with small amount of capital, our output is low. Yes, and if output is low, we consume this small amount. So that's not a good situation, and we should worry about it. Yes, when we this is the problem of each government, because people they underinvest, undersave, and then that's why firms underinvest. Yes. So we undersave, we want to consume now, that's why our saving rate is low, and that's why it's the problem of government. Igor Vladimirovich told you the example of Russia, how our government tries to make this the reform of pension system. Yes, yes. The main goal of this reform was to increase the saving rate. And what will happen? Let's do this reform. If we will increase the saving rate by conducting this reform, what we will see? What we will see? Higher saving rate will lead to higher level of investments. In the steady state, bigger amount of capital per worker, yes, and bigger output per worker. And we will see when we move from this steady state to this steady state, we will see the economic growth. Yes. And we will see this important effect of this reform. It's not true. Yes. So we'll move to the new amount of capital, higher level of output from equilibrium 0 to equilibrium 1. If we will increase the saving rate by conducting the reform. You see, technology stays the same, depreciation rate stays the same, we increased the saving rate. Let us write down this like our favorite. So if we will increase the saving rate, so investments will go up. That's why more capital we will have in the economy. So capital per worker will go up. We use capital to produce goods. So output per worker will go up. And that means economic growth. Yes. Okay. Also, my next question. Also, okay, my question I will show you another polar situation when we save almost everything. Nice question, no? Okay, when we save almost everything. Another note. There's also a new lecture. When saving rate almost 1. What it means that we will say, please.
Okay, I will suppose that it would lead to the crisis of overproduction, actually, because we invest a lot, but our consumers do not consume all these goods.
Yes, exactly. We save almost everything, so we consume a little bit. So we produce, we make like production for production. Yes, exactly. We invest a lot, but low consumption, low production. Yes. Or you can name it production for production. And it was the example of USSR, yes, in the lecture. Example, USSR. So what we can conclude that low saving rates, it's bad. Very high saving rates, it's also bad. And what is the best saving rate, please?
It's actually the golden rule, I suppose.
Mm-hmm. And what that means? Golden rule.
It means that we have such level of capital at which we have very high level of the capital itself and the rate of consumption. So it's what kind of imbalance? Or am I wrong?
Maybe I can hear. It's the best saving rate such that our consumption is maximized. Yes, consumption is maximized. Consumption.
Yeah.
Mm-hmm. So the best saving rate for us, for consumers, is golden rule saving rate. Golden rule such that our consumption is maximized. We know that how to count the consumptions. Our income minus savings. Yes. So in our model, it's output minus investments, because investments are equal to savings. Yes. So on the graph, this is output, these investments, and the difference between these two graphs is consumption. So this difference is consumption. And we should find such saving rate such that consumption is maximized. Now we have the depreciation rate. Yes, and the best saving rate will be when the slope of depreciation rate so depreciation rate will be equal to the slope of our production function. So we should be here. Yes, so our best saving rate will be like this. This is the biggest difference. Consumption maximums. So you can look at it in the lecture. So, and this saving rate, it is not super low, not super high, it's somewhere in the middle, such that consumption is maximized. It's the best for us, for consumers. So, what's up? Okay, here belongs from 0 to 1. So our statement is false. We should worry about the saving rate if it is low. And it's one of the biggest problem, one of the hardest problems of governments in reality. Okay, guys, please, any questions about saving rate? Okay, so I will erase and we will move. And we will do number 2. Please read. It's about Japan, 1945. Okay. In 1945, Nest, you want to answer?
Well, I can.
Let's read the task and then I'll ask. In 1945, Japan was the target of a number of large, heavy explosive devices. As you remember, let's imagine that these devices destroyed half of the country's capital without damaging the Japanese population. Let us write down. So, in 1945, in Japan, we had the shock of capital destruction. The shock of capital destruction such that amount of capital decreased, but population stayed the same. Yes, and we should explain what happened in the long run equilibrium, yes, by using the Solow model. What will happen with our GDP per capita, what will happen with the capital per worker. Let us prepare the graph. So before the shock, technology output, and here investments. Depreciation of capital. This is the situation 0. Yes, steady state before the shock. Before the shock, we had equilibrium capital per worker and output per worker. So, okay, who wants to explain what has happened? Next.
Well, I wanted to try because actually I didn't really get it, so maybe I will try to understand it more. So, as I understand, it should decrease actually because of the shock. So if we have a shock in economy, it means that our output is going down. So everything kind of is just going down. Actually, because of the, like, after 1945 in Japan, there was a huge boom. I mean, I'm not sure how to call it in English. It's in Russian. It's puzir. There was a kind of like economic bubble. I don't know. Yeah, and that was a really harsh situation in economy. Yeah.
I'm sorry, Nastya. Are we talking about right now 1944 or about 90s economic crisis in Japan? Because I didn't get. Maybe I have something messed up.
Our question for now: what has happened exactly after the shock? Yes, in 1945, after this capital destruction.
45.
Then what will happen in the long run? So during this 20th century, what was happening? Okay, that's
so,
true.
Yes.
Then,
so actually, I think that the decrease in the capital per worker should lead to the decrease in investments.
yes.
And if we have decrease in investments, I think that should lead to increase in interest rate.
Yes, yes. This was a point 3 in this class. So investments will go down, which will lead to higher interest rates. Yes, immediately. Yes, good. Okay, thank you. Let's listen to Maxim. Maxim, you want to add?
Yes, and of course the productivity and possible cost of the one labor unit, it depends on savings, and of course we know that savings were halved after the 1945, after the investment rates increase, the savings increase too, and after the 1945, the savings affect the labor force, which we have already because people survived, and that's why in the long run the situation will be better.
Better than
Not in the long run, not in the long run, but when the savings ratio will increase. So that period a bit after 1945, yes.
I agree that savings will increase after the shock, but it will begin to increase. After the shock. But I do not agree that saving rate will change, because we do not have such information about the saving rate. Saving rate is a number between 0 and 1. Yes, saving rate will not change, but amount of savings will go up. That's true. We will move along the curve of savings. We'll move along. There will be no shift, but we'll move along. Did you get?
Yeah, I перепутал два эти термина.
Okay, so good. That's true. So if I will ask you, after such capital destruction, what happened with the technology in Japan? Nothing. So technology will stay the same. So this curve, nothing happened with saving rate in the economy. So this curve for investments will stay the same, no shift. Depreciation rate stays the same. Yes, depreciation rate stays the same. So this line also will stay the same. So the steady state long run equilibrium will be the same as before the shock. But we see that we will have half of capital in 1945 after this capital destruction. So we will move where? Here, in this point. Half of capital. Yes. Now we're in K prime over N in 1945, half of capital destroyed. Yes, we're now here. And what we see? Immediately after this capital destruction, we will have lower amount of output, lower investments. Yes, as Nastya has said, lower investments, lower level of investments, you see? But when we are to the left from the steady state, you see what will happen to the capital. With such amount of capital in the country, with such a technology, same rate and the depreciation rate, our investments are higher than depreciation. You see the difference between these two graphs? Yes? So what means investments are bigger than depreciation? That means that capital is growing. So capital start growing, yes, and it will move back in the long run. It will move back to the steady state, and that's all. Capital start growing and go to the steady state, previous steady state. That's why output is growing, because we can produce more. We're using this higher capital. Yes? And this difference between investments and depreciation is lower. And here, capital does not change. Investments are equal to depreciation. No change in capital. So okay, let us write down this formula one more time. So the change in capital, how to write down? It's capital in year T plus 1 per worker minus capital in year T per worker. So this is the change in capital. Capital per worker. And it is equal to the difference between investments, how much we invest and how much we depreciate. So investments is our savings multiplied by the output, and that means our income in the economy, P over N, minus depreciation. Depreciation rate multiplied by capital per worker. So, and in the steady state, they are equal to each other. So the change in capital equal to 0, stable situation. Yes? So it is equal to 0 in the steady state. But after the shock, what we see? We see that investments are higher than depreciation. So investments higher than depreciation, so the difference is bigger than 0 after the shock. Yes, and what conclusion we made? That capital in year t plus 1 should be bigger than capital in year t. So capital begin to grow. So that means that capital will go up, capital per worker will go up, which will lead to output per worker will go up. So this is true only after the shock immediately, and then it will move back in the long run. Agree? Then savings begin to increase, as you have said, but depreciation also increases, but the difference matters between savings and depreciation. The difference is lower, 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 and in the steady state, the difference is equal to 0. Did you get the point? Okay. So we can draw this. We can draw this by using another diagrams. Let me show you other axes. So we'll use horizontal axis. Here will be time. Let us show this dynamic of capital per worker and output per worker. This will be capital per worker. In 1945, somewhere here, we will have the shock. So before the shock, we were in the steady state. So capital per worker were constant. Agree? Constant before the shock. So horizontal line. Then 1945, capital destruction and capital decreased by half. So it will jump by half. Yes, somewhere here. And then what is happening? Capital moves back to the steady state. So it will look like this. Time passes, capital will move back to the steady state. Agree? What about output? Output, the same. Yes, you see, output became lower. Yes, and then it moves back to the steady state level. So here will be K star over N. This is half K prime over N. And here, if we will look at output per worker, same graph, same dynamic. And here the shock. So output per worker, steady state. Then you see the jump down, and then moves back to the steady state level. And this is this output per worker. Okay, good. And also we should discuss this. I think about investments and interest rate. Nice to explain this exactly. That immediately investments will go down. That's why interest rate will jump, will go up. Because we remember this negative correlation between investments and interest rate. The high interest rate is more expensive to borrow. That's why lower investments. So negative connection. Yes. Lower investments, higher interest rates. Yes. So, but then what is happening then? Investments will go up. Yes. So say interest rate will go down slowly. Yes, back to the steady state level. Then our investments will go up. So we go down up to steady state. And we can show it also on the graph like this. Here time, here interest rate, steady state level before the shock, 1945, like R star. Yes, then we see the jump, immediate jump, and then it moves back to the steady state level. Like this. And how to understand this by using our models? The only thing that we know, if we will answer this question, what will happen to the real interest rate? We will think like this. Interest rate. It was in ISLM. In ISLM, we had IS. In IS, GDP consists of consumption, investments, government spendings, and net export. The only thing that is connected with interest rate is investments. We see investments here. So the investments are negatively connected with interest rate in the economy. And then we will see what will happen to investments. Yes, and we can answer about interest rate. Good. Okay, so it was the hardest task for today. Questions? Okay. So I will erase and please read the third task, our last task. And think intuitively, why is it so? From real life. So what we have in number 3? Elizabeth, you want to answer? Yes. So let me.
You just proposed a thing, so I can share my thoughts.
Let me explain the task, and then I will ask. So we have such connection in the task. Here, horizontal axis GDP per capita. GDP per capita. So it will show us economic growth if it grows. Yes. And vertical axis, it's urban air pollution, level of urban air pollution. And we have such empirical evidence that this connection between economic growth, between GDP per capita and urban air pollution level is U-shaped. So firstly it increases and then it decreases. And we should explain why we have upward sloping part and downward slope. Elizabeth, please.
Yeah, so about the upward sloping, I guess it's obvious that when the country starts to develop and when the GDP grows, it is strongly linked with the production and the my Wi-Fi connection is a bit unstable, sorry. So the air pollution is a result from the high industrialization, and that leads to such high rates of air pollution together with the rising GDP per capita.
Yes, exactly. Thank you. So let us write down explanation for this upward sloping part. So when the country is not super rich, yes, you see it starts increasing its GDP. So it's developing country. How countries develop? They invest in capital. Which capital? They invest in building cities, in factories, in production. Yes. And urban area increases. That's why air pollution increases. Yes, it's about developing countries. Or remember this I don't know, from history, or like after revolution, years of revolution in Russia, 1917 and stuff like this. It was industrialization. Yes, a lot of factories, a lot of pollution in the air. Yes, we understand this logic. Okay, but GDP is growing, so it's economic growth. So we explain this part. Let us write down this. So, mhm. So we invest in capital, and explain in which capital. Capital is buildings, factories, or I don't know what else, infrastructure, stuff like this. And capital, so buildings, factories, amount of factories increases, infrastructure, for cities, yes, for cities, number of cities increases, which will lead, on the one hand, we invest in capital increases, on the one hand, it increases GDP per capita, but on the other hand, air pollution increases. Yes, and that's true for developing countries, not super rich countries. You see, the amount of GDP per capita is low in this part. It's for developing countries. And how to explain the second part? And we see this correlation, with this negative correlation between higher GDP per capita and lower urban air pollution. Next, please.
I think it can be also quite easily explained, because let's just imagine, for example, I think China is a good example here, because in China the production is very high and the development of the country is really high, but actually that is why, because of the development, there are a lot of manufactories functioning there, and just because of this we can say that this would be the negative put a negative effect on the air pollution. So probably this can be the explanation of the downward sloping part.
But higher GDP, lower pollution.
Yes, that was
no.
Lower you mean okay, I got it. So okay, for this example, we can take the countries like Norway, I don't know, Sweden, with a high GDP and a really good economic situation and conditions, because they really protect and put and pay attention to this, put to this situation. So
yes, exactly. Main example is all Europe. Yes, they have so much money, so they have money to care about the environment.
All Europe is not an example.
Okay. No. Okay, so the most developed countries, as you have said, so they have money to think not about how to feed people, yes, but how to care about how to protect environment. Yes, that's why they invest in. They have money to. They have enough income to invest in eco-friendly capital. Yes, you see this example in, I don't know, in Netherlands, or where else? In Germany, yes, something like this. So, yes, so this part is for developed countries. Yes, rich countries. You see? Let us write down this. So, this for developed countries. Rich countries. They want to increase their GDP. They need this economic growth also, but when they will invest in capital, they will invest in eco-friendly capital. They will care about environment. care about environment. Invest in eco-friendly capital, which will lead to, on the one hand, economic growth, which will lead to the increase in GDP per capita, but on the other hand, it will reduce air pollution, or urban air pollution. Agree? So it's the example from macro theory. So this condition, yes. If you are a poor country, you invest in cheap capital and not eco-friendly cheap capital, yes, for industrialization to increase your GDP per capita. But then you become rich and you have enough money to care about environment. And this is macro example. Let us remember example from microeconomics. Do you remember about goods? We have normal goods and inferior goods. So normal goods and inferior. If the good is normal for you, what that means? Higher income will lead to higher demand for this good. Yes. Good quality good. Higher income will lead to higher demand. But if this good is inferior for you, that what that means? So this is the good of bad quality. Yes, and higher income. With higher income, you will substitute consuming this good with better quality goods. So your demand for these inferior goods will go down. And you see, we can connect this micro example of bad quality good with such situation. Here you see GDP per capita, it is income. Yes, it is income. And I don't know, this is some good. And if you're poor, if you're a poor student with higher income, if you're a poor student with higher income, you will consume more, I don't know, very cheap bread. I don't know. So bad quality good is normal for you right now. You will consume more. Yes, but then you become rich, you graduate from your university, you have a lot of money, and the higher your income, now the lower the consumption of this bad quality good for you. Yes, you will substitute this bad quality good with consuming good quality food, something like this. Yes, and you see, this is the same intuition, the same logic. So you substitute, you change. It's not the change of preferences, it's your preferences conditioned on income, on your income. And it's the same for countries. If you're a poor country, you do not care about pollution. So, but if you're rich, you have enough money, yes, to care about environment. So pollution will decrease. You see, explanations are the same, but a lot of students think that micro and macro are super different courses, but that's not true. And the main goal of this economic theory course is to put a seed of economic intuition. Yes, so to make you think like economists. Yes, in these terms and something like this. So, okay, that's all that what I wanted to explain to you. Considering this class, any questions, please? About this class, about previous classes?
Okay. What we will do with the 11th class?
Yeah, the last one.
We have 11, right?
I mean,
What?
we have 11 lectures and 11 presentations.
But 10th and 11th 10th and 11th lecture was about Solow model, and this class is about Solow model, so it
Okay.
covers 10th and 12th section.
Okay, thank you. Yes.
Okay.
This is the last seminar today.
Yeah, that is why I was just asking.
Everything is okay. So I'm scared, really. No,
That's fine.
that's all about our classes. So we will see each other next Wednesday. Finally, I'm really happy that we will see each other.
Yeah. Oh, and actually, I have a question. I was told by Ella Chromova, I don't know her отчество, sorry, that we can take with us our notes. I mean, our copybook, for example, where we, for example, wrote everything from the lectures, from seminars. So is it possible? I mean,
The previous group, I think group number 3, before you, told me that Professor Avtonomov told you about this during the lecture. But I didn't hear because I didn't watch all the lecture, but you can watch the beginning of the lecture and the end of the lecture, and you can record it to show the proof that, yes.
okay, I see. Okay.
Yes. But I don't know the answer, but I heard that that's true. But
yeah, I think that's true because everybody is talking about it. So yeah, in general, I think